Friends, in the last video, we have calculated a rank of a matrix by using normal form of a matrix. Now, I want to introduce one more form, namely Echelon form. So, you may ask, what do you mean by Echelon form? A matrix A is said to be in Echelon form if it satisfies the following conditions. So, first condition is the first non-zero element in each row is called its leading entry and it should be 1. Second condition is in any two successive rows, ith row and I plus 1th row, that do not consist entirely of zeros, the leading element in the I plus 1th row lies to the right of the leading element in ith row. Last condition, any rows that consist entirely of 0 lie at the bottom of the matrix. Any matrix satisfies these three conditions, that form we call it as an Echelon form. Sometimes we call row reduced Echelon form. So you may ask, what do you mean by row reduced Echelon form? A matrix is said to be in row reduced Echelon form if, in addition to the conditions 1 to 3, just now we have explained what do you mean by 1, 2 and 3. It is also true that in a column that contains the leading entry of a row, all the other elements are 0. So I will give some examples for Echelon form as well as for row reduced Echelon form. For example, say A is equal to, so this is the matrix. Now I will call it as an Echelon form. So you can verify whether it satisfies the conditions or not. So first condition is non-zero element in each row. So here 1 is the non-zero element and it is 1. Is it clear? So this number we call it as an leading entry. And when we consider these two rows, so this is the leading entry. Next leading entry is also 1 and it is its right hand side. So therefore this matrix is called Echelon form of a matrix. Similarly, here 1 is the leading element. 1 is the leading element, right hand side of this element. Right hand side of this element is 1. Right hand side of previous leading element. Is it clear? So these four are the leading elements. Therefore these two are examples of Echelon form. Right? And similarly, you can consider a matrix A is equal to, it is given that 0, 1, 0, 2, 0, 5, 0, right? 0, 0, 1, 1, 0, 3, 2 and so on, right? So non-zero element is 1, leading element. Non-zero element 1, leading element. Non-zero element and its right hand side of a previous leading element. So therefore, so it is an row reduced Echelon form. What is the fourth condition? So this is the leading element in the second row. In this column, other elements are 0. So 1 is the leading element, other elements are 0. 1 is the leading element, other elements are 0. Similarly, 1 is the leading element, other elements are 0. So 1 is the leading element, other elements are 0. 1 is the leading element, other elements are 0. So these two are examples of row reduced Echelon form. Similarly, 1 is the leading element, 1 is the leading element, other elements are 0. 1 is the leading element, other elements are 0. Therefore, these three are examples of row reduced Echelon form. So now, reduce the following matrix to its Echelon and its row reduced Echelon form. Say for example, now I want to call it as an A is equal to, it is given that first row, second row, third row, fourth row. How many rows are there? 4. 1, 2, 3, 4, 5. 4 by 5 matrix. So now I can apply an operator or 1, 2. So I can interchange first and second row. So you can obtain an equivalent matrix 2, 4, 8, 2, 4. First row is 0, 1, 2, 0, 3. Other two rows remains as it is. So that's why I am going to write as it is 1, 2, 4, 2, 2. And last row is 1, 3, 6, 1, 5. Right? So I have obtained a new equivalent matrix. So observe the first row 2, 4, 8, 2, 4. So now I want to change R1. R1 is equal to R1 divided by 2. Right? So you will get an equivalent matrix. So what is the equivalent matrix? So first row is divided by 2. 2 divided by 2 is 1. So 4 divided by 2, 2. 8 divided by 2, 4. 2 divided by 2, 1. 4 divided by 2. Right? And other rows remains as it is. So 0, 1, 2, 0, 3. So 1, 2, 4, 2, 2. 1, 3, 6, 1, 5. Right? So now I can operate R3 is equal to R3 minus R1. R3 minus R1. 1 minus 1. 2 minus 2. 4 minus 4. Right? So I can similarly I can operate R4 is equal to R4 minus R1. 1, 2, 3, 4. R4 minus R1. 1 minus 1. Right? 3 minus 2. 6 minus 4, etc. So you'll get an equivalent matrix. Right? R3 and R4 will change. First row remains as it is 1, 2, 4, 1, 2. First row. Second row is also 0, 1, 2, 0, 3. R3 is going to change. R3 minus R1. 1 minus 1. So 0. 2 minus 2. 0. 4 minus 4. 0. 2 minus 1 means 1. 2 minus 2. 0. Similarly R4 minus R1. Right? R4 minus R1. 1 minus 1. 0. 3 minus 2. 1. 6 minus 4. 2. 1 minus 1. 0. 5 minus 2. 3. So you will get a new matrix. Right? So one more operator is R4 is equal to R4 minus R2. 1 minus 1. 2 minus 2. 3 minus 3. So what is the equivalent matrix? Right? So first row as it is 1, 2, 4, 1, 2. Second row 0, 1, 2, 0, 3. Third row also 0, 0, 0, 1, 0. R4 is going to change. R4 minus R2. So 0 minus 0, 0. 1 minus 1, 0. 2 minus 2, 0. 0 minus 0. 3 minus 3. I hope we have obtained a new equivalent matrix. Is it clear? Right? So now you can verify the first three conditions. That's why I can say that. So this is an Echelon form. What is the leading element? 1 is the leading element. 1 is the leading element. 1 is the leading element in the third row. Right? So now I can reduce the same matrix to an row reduced Echelon form. Right? So for that reason I can operate an operator. Say for example R1 is equal to R1 minus 2 times of R2 because I want to make this 2 as 0. For that reason I can apply and I can obtain equivalent matrix, right? So R1 is equal to R1 minus 2 times of R2, 1 minus 0, it remains 1 only, right? So 2 minus 2, it becomes 0. So 4 minus 2 into 2, 4. 4 minus 4 is 0. 1 minus 0, 1 only. So 2 minus 6, it means minus 4. Other rows remains as it is. So 0, 1, 2, 0, 3, right? So 0, 0, 0, 1, 0, and the last row remains as it is, right? So this is the new equivalent matrix. Now I can operate R1 is equal to R1 minus R3, right? Again R1 is going to change. So 1 minus 0, it means 1 only. 0 minus 0, 0 minus 0, 1 minus 1, 0, minus 4 minus 0, minus 4 only, right? So R2, 0, 1, 2, 0, 3. Next row as it is, 1, 0. Last row as it is. So we have obtained a new matrix. Is it clear? Right? So now we can verify. 1 is the leading element, other elements are 0. 1 is the leading element, other elements are 0. 1 is the leading element, other elements in this column are 0. It means this matrix satisfies all the 4 conditions. Therefore it can be said that this matrix is a row reduced matrix. Thank you.